Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are getting. And we'll be looking at the levels of CSEC Form 5 exams and Form 6 KEEP exams. In this video, we'll be looking at specifically CSEC Mathematics and the topic of measurement. We'll be focusing in measurement on perimeter, area, and volume. This is the third video in this series dealing with past paper questions from May 2019 until the present. Feel free to like the video and add any comments down below so we can help you in any areas that you need. Don't forget to look at the description where we give the layout of how we should be looking at all the videos to cover the entire of CSEC Math past paper questions. Let's take a quick recap of the major topics in CSEC Math, of which there are 10 of them. And in this video, we are dealing with number 4, measurement. Measurement itself comes as 8 questions in the multiple choice paper, paper 1, and 1 full question in paper 2 with 9 marks. This topic can be subdivided into 2 main areas: scale drawings and perimeter area and volume. In this video, we'll be looking at perimeter area and volume. And let's recall that in both papers in the formula sheet, there are 8 formulas that are given to us, which are along this topic. The first being volume of a prism, volume of a cylinder, volume of a pyramid, circumference of a circle, length of an arc, area of a circle, area of a sector, and area of a trapezium. Let's give a quick summary of this topic, where we look at the shapes from rectangles, squares, parallelograms, straight onto cone. And these are the major shapes that are tested. And how can we subdivide them? Well, from rectangles, squares, straight onto circle, those shapes are flat, so we can call them two-dimensional shapes. While the others, from cuboid, cube, cylinder, pyramid, and cone, those are three-dimensional shapes. So if we consider the perimeter of these shapes, remember perimeter means the distance around the entire shape. Then from the rectangle to the trapezium, we can use one formula to find the perimeter of all these shapes. And simply, it is to add up all the lengths of all the sides. While for a circle, because we can't see any straight sides there, then the formula is 2 times pi times r. And notice there's an asterisk there. And any formula with an asterisk on this table indicates that it is given in the formula sheet that we are given by the CXC body when we are writing both paper 1 and paper 2. And for the three-dimensional shapes, all of them, then we cannot find the perimeter around them because they are not flat shapes. Now let's look at area. Area can be considered to be the number of squares that are required to cover the entire shape. So for a rectangle, then it straight up to trapezium, from a rectangle up to rhombus, all those will be length times breadth, as long as the length and the breadth are at 90 degrees to each other. While for the triangle, it is half of a rectangle. And for the trapezium, it is a half a plus b by h. Notice that's also given in the formula sheet as well, where a and b are the parallel sides of the trapezium. And for circle, the area of a circle is pi r squared. And how do we find the area of the 3D shapes? Well, all those 3D shapes have multiple sides. So what they will be asking us will be to find the surface area, or the area of all the surfaces. So what we need to do is find the area of each surface and add it up. And for volume now, last part, for the volume of the two-dimensional shapes, volume would be considered to be the number of cubes that are required to fill the entire shape. And since these two-dimensional shapes are flat, then we cannot find the volume of these shapes. And the volume of the cuboid, cube, and cylinder, those which are what we call prisms, then it will be the area of the cross-section times the length or the height. Doesn't really matter what we call it. And for the pyramid and cone, then it will be 1/3 the area times the height. May 2019, number 6b. The diagram below, not drawn to scale, shows the cross-section of two cylindrical jars, jar X and jar Y. The diameters of jar X and jar Y are 3D centimeters and D centimeters respectively, and we can see that from our diagram. Initially, jar Y is empty and jar X contains water to a height or depth of 4 centimeters. Part 1. Determine, in terms of pi and d, the volume of water in jar X. This means that when we work out the volume, our answer should include pi and d. So, let's look at jar X. What shape is that? That is a cylinder. And if we look in our formula sheet, they gave us the formula for the volume of a cylinder. So volume of jar X is equal to, it is a prism, area times height, and if we substitute for a cylinder, volume of X is equal to pi r squared times h. And we can now substitute because we know r. So Vx is equal to pi times, if the diameter is 3d, then the radius will be half of that. So it will be 3d over 2 times 3d over 2 times the height, which is 4. And 2, we can cancel out. 2 into 2, 1, 2 into 4, 2, 2 into 2, 1, 2 into 2, 1. So we're left with pi times 3d times 3d. So 3 times 3 is 9 pi, and d by d is d squared. Part 2. If all the water from jar X is now poured into jar Y, calculate the height it will reach. So what that means is that the volume of water in X will now be equal to the volume of water in Y, because we've taken all the water in jar X and poured it into jar Y. So we can substitute. We worked out in part 1 the volume of X, that is 9 pi d squared, and the volume of jar Y will be following the same formula, pi r squared. And we know r, because for jar Y, the diameter is d, so r is d over 2. So we get 9 pi d squared is equal to pi times, what's r for jar Y? D over 2 times d over 2 times h, because that is what we want to find, the height of water in jar Y. And obviously, since it's a thinner jar, the height will be much greater than 4. So if we want h alone on the right hand side, we need to carry things across. So we already have 9 pi d squared, and if we have pi is multiplying on the right hand side, when we carry it across, it will divide. And we have d times d, which is d squared on the right hand side. When we carry it across, it will divide, it will end up in the denominator. So we have pi d squared in the denominator. And we have 2 times 2 on the right hand side. They are both in the denominator. So when you carry it across, it will be in the numerator. As such, we can solve. We can cancel pi on top and pi below. D squared cancels with d squared. So we're left with 9 times 2 times 2. 2 2s are 4. 9 fours are 36 centimeters. So the height of water in jar X will be 36 centimeters. May 2021, number 6. Farmer Brown makes troughs to feed his farm animals using wood that is 5 centimeters thick. As shown in the diagram below, the troughs are rectangular based, open at the top, and have external dimensions of 300 centimeters by 190 centimeters by 160 centimeters. Part A. Show by calculation that the internal capacity volume of the trough is 8,091,000 centimeter cube. So let's recall that volume would be length times breadth times height for a cuboid. Now, what is the internal length? If we go that the external is 300 centimeters and we remove 5 centimeters on the left hand side and 5 centimeters on the right hand side, then the length on the inside would be 300 minus 5 minus 5. So we can say 300 minus 2 5s. 2 5s are 10, so 300 minus 10 is equal to 290 centimeters. Let's do the same thing with the breadth. The breadth is 190 centimeters on the outside. So on the inside, the internal one, it'll be 190 minus 2 sides, the front and the back. So 190 minus 2 times 5, 2 5s are 10. So 190 minus 10 is equal to 180 centimeters. And finally, for the depth or the height, which is 160 centimeters. In this case, there is no top, so we only need to remove the base. So it's 160 minus 1 times 5. 1 5 is 5, so 160 minus 5 is equal to 155 centimeters. As such, let's recall that the volume of a cuboid, it falls under that of a prism because it has the same cross-sectional area throughout. So volume of the inside will be area times height. And we know the area of the base is length times breadth times height will give us the volume. And if we substitute the internal dimensions, because it's the internal volume we want, it'll be 290 times 180 times 155. And if we use our calculators, this will give us a value of 8,091,000 centimeter cube. And since we've proven this, we can show this by writing QED at the base, quod erat demonstrum. And now if we go on to part B, calculate the volume of wood needed to make a trough. So if we need to calculate this volume, we can do it a couple different ways. One way is we can work out the volume of the front wall and then the back and then the right and left, taking out any parts that are repeated and the base. Or a simpler method would be to find the volume of the entire object and minus it from the internal volume, and that will give us the volume of the trough. So since that second method seems a little easier, let's try that. So the volume of a cuboid, which is area by height, is length, and the area is length times breadth times height. And how can we use this? Because a cuboid falls under the area of prisms. So volume of a cuboid will be 300 times 190 times 160. Remember, this is the external volume we're finding. And using our calculators, that will give us 9,120,000 centimeter cubes. So the volume of the trough is equal to the volume of the cuboid, the entire cuboid, minus the volume of the inside, which we've worked out in part A. So if we substitute, it will be 9,120,000 minus 8,091,000. Using our calculators, this gives us 1,029,000 centimeter cube. May 2021, number 6, part C. Farmer Brown must paint the internal surface of the trough, meaning the inside. That means there are 4 walls, the inside of it and the base. Given that 1 gallon of paint covers approximately 280 centimeters squared of surface, determine the total amount of paint in liters that is needed to paint the internal surface of the trough. And take 1 gallon to be equal to 3.79 liters. So first of all, we need to calculate the surface area of the internal surface area of the cuboid or prism. So if we look at the front surface, the area of the front rectangle, it will not be the external dimensions or measurements, but the internal ones, because we're painting the inside. So area of a front rectangle is the length times breadth, and the length won't be 300, but it'll be 290, the internal dimension or the internal length, times the height, and the height will be 155. Remember, 160 is the entire thing, but it's the inside of it. We have to take off for the base. And we use our calculators. 290 by 155 is equal to 44,950. The area of the rear rectangle follows these exact values, length times breadth, which is 290 by 155, and it'll give us the same 44,950. For the rectangle on the right side, the area of it, on the inside of it, would be not 190, but 180 times 155, which is 27,900. Area of the left rectangle will give us the same thing. And the area of the base would be 290 times 180, which is 52,200. Now that we've gotten the area of each of the 5 surfaces, how do we get the entire surface area of the internal prism? It will be, we'll have to add up all the 5 values. And using our calculators, and we add it up, we get 197,900 centimeters squared. So this is this entire surface area on the inside of the trough, which needs to be painted. Now, let's recall that 1 gallon is equal to 3.79 liters. And it was given that 1 gallon is the same painting a surface of 280,000 centimeters squared. So we can replace it. 280,000 centimeters squared is equal to 3.79 liters. And we have a ratio. So 1 centimeter squared will be equal to 3.79 divided by 280,000. And if we want for what is the entire surface area? 197,900 centimeters squared. So it'll be 3.79 divided by 280,000 multiplied by 197,900 liters. And using our calculators, we can multiply the numerators and then divide by the denominator. That will give us 2.6787 liters. However, more than likely, when we're buying gallons of paint or paint in general, we will be able to buy in liters. So we can't really buy 2.67. More than likely, he will be able to buy 3 liters of paint. May 2022, number 6. The diagram below shows a solid made from a semicircular base with a rectangular prism above it. The diameter of the cylindrical base and the width of the rectangular prism are 4 centimeters each. So what that means is we had a complete cylinder cut in half as our base, and directly on top it, with the same width of 4 centimeters, is a cuboid. Part A. Calculate the total surface area of the solid. So the surface area of a cylinder with a radius r is given as A is equal to 2 pi r squared plus 2 pi r h. So first of all, let's work out the area of that semicircular cylinder. And that will be half of the area of the cylinder. So it will be a half times 2 pi r squared plus 2 pi r h. And if we substitute, we're going to get a half times 2 times pi is 22 over 7 times 4 times 4, because the radius is 4, plus 2 times 22 over 7 times 4 times 12. 12 is the height or the length of the cylinder. And that works out to be, using our calculators, 201.15 centimeters squared. So the total surface area of the solid will be the area of that semicircular cylinder plus the area of all 5 sides of the cuboid. Not the area of the base, because that is hidden. So we want to add up these 6 things. So the area of the semicircular cylinder is 201.15. The area of the front rectangle that we're seeing there is length by breadth, which is 12 by 4, which is 48. Area of the rear rectangle, the one at the back, will be the same thing, 48. The area of the rectangle on the right hand side will be length by breadth, 4 by 4, which is 16. Area on the left will be the same thing, 16. And area of the top rectangle, which is length by breadth, will be 12 by 4, which is 48. So if we come and add up all 6 of them, that will give us our surface area, which works out to be 377.15 centimeters squared. Part B. Calculate the volume of the solid. Since this is a prism, then to find the volume of the prism will be the area of the cross-section times the length of the prism, or height. And this is given as the first formula on the formula sheet. So how do we find the area of the cross-section? If we look on the right-hand side and we look at that cross-section, we have half a circle at the base. So that will be half of the area of a circle, half pi r squared, plus a rectangle, length by breadth. And if we substitute, it will be a half times 22 over 7 times 4 times 4, plus length by breadth is 4 by 4. And that works out to be, using our calculators, 41.14 centimeters squared. So that's the area of the cross-section. And how do you find the volume of a prism, or volume of the solid? It will be the area of the cross-section times the height or the length, which will be 41.14 times 12, which works out to be 493.68 centimeter cubed. May 2022, number 6C. The solid is made from gold. 1 cubic centimeter of gold has a mass of 19.3 grams. The cost of 1 gram of gold is $42.62. Calculate the cost of the gold used to make the solid. So we know 1 centimeter cube or cubic centimeter of gold is 19.3 grams. And we worked out the volume in part B, which is 493.68 centimeter cubed. And if we multiply by 19.3 grams, will give us 9,528.024 grams of gold. And 1 gram of gold is worth $42.62. So 9,528.024 grams of gold will work out to be 42.62 times that. And that works out to be $406,084.38. We've come to the end of this video on CSEC past paper questions, specifically on the fourth topic of the syllabus, measurement, which focused on the subtopic perimeter, area, and volume. The first video in this series did 5 past paper questions from May 2009 to 2013. The second went from 2014 to 2018, and this video continued the trend starting at 2019 until the present. Feel free to look at the description down below to follow the playlist of videos so that you can cover the entire CSEC Maths syllabus so that you get a better understanding and eventually improve your grade.